name is Angelina, and I'll be talking about the warm colors in chemistry. Color theory. Color theory categorizes colors into warm and cool tones based on their visual temperature. Warm colors include red, orange, and yellow, which are often associated with warm colors. And that's what I will be talking about in this presentation. Warm colors often have high saturation, making them appear more vivid and lively. The hue is the specific color itself, while saturation refers to the intensity of the color. Higher saturation tends to make warm colors more striking and attention-grabbing. In this right lower corner, I have the color wheel for the warm colors. In pigments like paint, warm colors are made by mixing various substances. For example, red can be created by using cadmium red pigment, while yellow can come from cadmium yellow or lemon yellow pigments. When combined, they produce vibrant warm shades. The color red in chemistry is often associated with warm colors is primarily a result of the way light interacts with matter, specifically through absorption and emission processes. The wavelength red has the longest in the visible spectrum, ranging from about 620 to 750 nanometers. Light consists of electromagnetic waves with different wavelengths, which I spoke of one. Visible light, which is the portion of the spectrum humans can see, ranges about 400 nanometers to 700 nanometers. Red as a color in chemistry is tied to the behavior of light in relation to the energy levels of atoms and molecules, as well as the temperature-dependent emission of light. The red color is a result of specific wavelengths of light being emitted or reflected by substances, and it could also be a signature of certain chemical species or temperature ranges in various chemical reactions. These are all the red fruits. And fun fact, the color red of many red fruits is a result of anthocyanin pigments they contain. These pigments absorb certain wavelengths of light and reflect red light, which are perceived as fruit colors. The specific shade can also depend on the pH and the chemical structure of the anthocyanin. Okay. Certain metal oxidize, iron oxide, produce red colors, often using pigments and dyes. By the way, orange. The color orange we see in fruits, flowers, and other materials is primarily due to pigments like carotenoids, which absorb blue and green light and reflects yellow to red wavelengths, which blend to form orange. The orange color we perceive is the result of selective absorption and reflection of light in the visible spectrum, specifically in the wavelength range of 590 to 620 nanometers. Some pH indicators turn orange in specific pH ranges, signaling acidity, or neutrality. I'm saying that wrong, I'm so sorry. Yellow. The color yellow in nature and materials come from primarily from pigments like carotenoids that absorb blue and green light and reflects light in the yellow part of the spectrum. The key to the color yellow is conjugated double bond structures in these pigments, which allows them to absorb light in the blue region, 400 to 500 nanometers, and to reflect light in the yellow regions, 570 to 590 nanometers. Okay. In addition to carotenoids, other molecules like flavonoids and also contributes to yellow coloration, especially in plants. Flowers like sunflowers or dandelions are yellow due to the variety of flavonoids and carotenoids that absorb light in the blue range and reflect yellow wavelengths. The chemical compounds of yellow, including includes cadmium sulfide and certain azidides, are yellow and are used in pigments and organic synthesis. Yellow could also be in the indicators for pH levels.
Cool colors. Cool colors have the ability to evoke emotions in people. The three cool colors I will include in this presentation are blue, purple, and green. Blue is known to be associated with sadness and depression. Purple is known to be associated with the feeling of creativity and wisdom. Green is known to be associated with the feeling of calmness and balance. Blue. When compounds absorb longer wavelengths of light, they reflect primarily the blue wavelengths. Certain chemical structures containing elements such as cobalt or copper can be mixed with other materials. This combination produces a blue pigment. Other elements such as indium 49 and cesium 55 show blue emission spectrum. Indigo and delphidin are two well known natural occurring organic compounds that have a bluish color. Purple. Purple is not a single wavelength of light on the color spectrum. Instead, it is a combination of red and blue wavelengths. In 1813, the chemical iodine was first isolated from vapor gas by acidic treatment of seaweed ash. The vapor gave off a purple color. The chemical compounds used for purple are cobalt violet, manganese violet, and various quinacridone pigments. Mixing these elements will give different shades of purple. Amethyst is a type of quartz that has a purple color. The purple color comes from a mixture of iron impurities and radiation exposure. When amethyst is exposed to radiation from potassium 40, uranium, and thorium in the rocks and soil around it, the radiation oxides the iron impurities in the quartz, making it purple. Green. The color green is typically associated with the element chlorine. Chlorophyll is what gives plants their green color. Compounds of the element copper are used to create the color green. Green light is reflected with specific chemical compounds cause selective absorption of wavelengths. The stone emeralds gain their color from trace amounts of chromium, vanadium, and sometimes iron.
Tertiary colors in chemistry. What are tertiary colors? Tertiary, third of the third rank, are colors combined of primary, which is red, yellow, and blue, and secondary, which is orange, purple, green colors. Mixing these colors creates 6 standard tertiary colors. Number 1, vermilion, 2, amber, 3, chartreuse, 4, teal, 5, indigo, 6, magenta. Although these are all fascinating colors to cover, I will be focusing on 3 specifically: vermilion, indigo, and amber. What is their history? How is chemistry involved in these specific colors? Where in nature may we find them? And if you see on the right, I have a little diagram of the primary, secondary, tertiary colors, which is called the color wheel. Vermilion. Vermilion is a vibrant red and orange color synthetically created from lead mixed with a red mineral containing mercury and sulfur called cinnabar. Although cinnabar is highly poisonous and toxic, it can be produced artificially and possibly still is used in traditional Chinese medicine. Cinnabar's chemical formula is mercury sulfide, HGS. Vermilion has a chemical formula that includes lead-2, lead-5 oxide, which is Pb3O4, that creates the red pigment. Not used properly, some toxic effects using red lead can affect the nervous, hematological, renal, and reproductive system, resulting in anemia, kidney impairments, etc. Vermilion can darken over time, which is an occurrence in the picture below. Arizona's famous red layer canyons, the Wave, Antelope Canyon, Red Tail Canyon, And the picture on the left, which is the larger enlarged one, is Antelope Canyon, which I took myself last April 2023. That was formed, which they call the Lady in Red. And on the right is just a natural picture of the canyons. And you can see the red pigment all over it. And another fun fact, the name originated from Chinese astrology. It represented the fire element called vermilion bird, the immortal bird covered in flames, referring to a phoenix. Indigo. Indigo is one of the oldest pigments used for dyeing and printing. Indigo is created from a plant called Indigofera tinctoria, also known as true indigo. It's also related to cabbage. It is used in many forms as hair dye, soil improvement, Indian and Chinese medicine, treating liver disease, heart disease, and relieving constipation as well as burn wounds. Indigo is insoluble in water, alcohol, and ether, soluble to chloroform and sulfuric acid. It can melt at temperatures as 390 to 392 Celsius. Indigo's chemical formula includes carbon, hydrogen, nitrogen, and oxygen, which is C16H10 and 2O2. Fun fact, indigo is used worldwide. Japanese use it for the anti-inflammatory benefits, especially for sensitive skin. Native Americans used it to dye their clothes to be able to distinguish their tribes from afar. And lastly, my favorite, amber. Amber is a warm golden color blended of yellow and orange. The name originated from resin that oozed out of trees that are now extinct from about 30 million years ago. It's a yellow, translucent, fossilized material with special properties. The color can be determined by the tree origin bubbles, which the more bubbles which retract the light, the lighter the amber will be, oxidation and evaporation process, and heat. One iconic property amber has is that it produces static electricity by its magnetic power. Amber is high in demand for jewelry that includes fossils with insects, as you see to the left, bottom left, and science purposes. It is combined with 78% carbon, 10% hydrogen, 11% oxygen, and small amounts of sulfur. Its complete chemical formula is C10H16O. And the last fun fact that we have is the word electricity was named after amber by the Greek philosopher Thales of Miletus. When amber is rubbed together, it creates an electrical charge that allows objects that are light in weight, feathers, to be lifted. And that is all. Thank you so much.